particles L. Okay. Whoops. So we got our left and right particles and our navigation rays. And I kind of feel like that's enough, actually. I think that'll be enough to implement simple movement. So, what should we say? if navigation ray.l dot is colliding. Okay, I'm gonna have to remind myself what this RayCast looks like in the docs. RayCast2D is actually what we want. Okay, cast tube is used to query. Yep. Can you Okay, before we do anything, let's go into our Viper code and make sure our raycasts are set up correctly. So we do care about the player. We don't care about other players. We definitely care about the environment. Don't care about collectibles. We do care about the player chain. Don't care about other players. Don't care about projectiles. Okay, cool. What's this collide with? Bodies, yep. Fantastic. Fantastic. What is that saying? Turns a boolean. So we want to say if navigation ray left and navigation ray R dot is colliding. And in fact, I want to extract this maybe. So we'll say like a private. Wait, it's not private, but let's have a look. Both rays colliding is going to return a bool, and let's just return that. So if both rays colliding, right, then slow and spin, right? We'll pass delta in. And we need to implement that. So func slow and spin with a delta. And this is a void function. We may as well put it in there. Okay, so what are we going to do? We're going to apply impulse, and I wonder whether this is actually, instead of process, this should be integrate forces. And here we apply an impulse of a constant that we'll put up here. So we'll say slow impulse equals a vector 2 of 0 in the x-axis and let's just say like a 10 in the Y, and we just want to apply creepy ice cream man jingling his bells in the distance. I don't know if you can hear that. Okay, so we're going to apply an impulse on the center of the enemy, and we're going to apply the slow impulse. Oh, we should be using snake case because this is not JavaScript. Alright, so we're going to apply a sort of a backwards force. So we essentially send out some feelers, those rays that we cast out of the enemy, right, those blue lines, they're essentially like feelers. And if both of them are hitting a rock or something, then we know like we're probably heading for a collision. So the first thing we want to do is apply a slow down impulse. So basically just start thrusting backwards. Right? What are these things complaining about? State is never used. Okay. This one's never used either. We might use state, who knows. I think I'm going to use the rotation velocity, angular velocity. In fact, I'm going to use it right now, so I don't know what I'm doing. So we pass the state in here, and we get it back in here, and so this state is going to be what's it? Something a force 2D physics state 2D or something. Integrate forces. Physics 2D direct body state. Bit of a mouthful. Okay, so let's just type that as that, so we know what we're dealing with. Okay, so that as well. Cool. So the first thing we want to do is we want to slow down, and then we're going to say state dot get something, angular momentum or something. Linear angular. I want angular velocity. Oh yeah, angular. Sorry, I get our angular velocity, and what do we do with it? Well, I think we multiply it, right? So we say if angular velocity is equal to 0, then return, right? So like we don't know which way we're going. Otherwise, if state dot angular velocity is greater than 0, then spin is greater than 0, so then we want to spin right. Else spin left, right? I don't know why I'm wrapping these things in parentheses. Okay. What are you complaining about now? Spin right, yeah, it's not defined yet. Cool. Func spin right and func spin left. Let's just pass there. What do we do? Well, first of all, particles.l.emitting should be false, and the particles right.emitting should be true. And let's duplicate that down here and just flip those around. Okay. And yeah, we should call this const spin impulse, right? And that is just going to be, let's say, like a 10.0. And okay, and then in this case, so actually what we want to do is, if both rays colliding slow, right? And then here we would say, oh, sorry, yeah, no, I was wrong. Okay, slow and spin, yep. Spin right, spin left. Cool. Slow and spin, and this actually should be a return. And then if no rays colliding, return full thrust. Okay, and so let's implement that. So func no rays colliding, and that is returning a bool as well, and it's going to look a little bit like this, but we just negate both. Oops. Both of these. And then full thrust, it's pretty easy to implement. So we can say full thrust, and both of those are going to equal true. And we want to apply an impulse, and we'll just say thrust impulse. Yoink. Thrust impulse of about 20. Okay. Full thrust. What are you complaining about? Oh yeah, we don't need the state first. Cool. And then I actually think this back slow impulse needs to be quite a bit more, maybe. Okay, and then if we spin, let's apply torque impulse of the spin right is just going to be the spin impulse, and spin left is just going to be the negative spin impulse, right?